This is the Jordan, Iowa F5 tornado of 1976, and it's quite possibly the strongest tornado you've never heard of. To make it even more terrifying, it wasn't alone. It constantly had multiple other tornadoes swirling around the main one in what can be described as a true tornado nightmare. It's June 13th, 1976, and the sun is scorching the earth in central Iowa. By mid-afternoon, temperatures across the state had soared into the 90s. While to many this was just a typical beautiful summer day, it was much more sinister than that. As the sun heated up the surface, the atmosphere in turn built up energy for thunderstorms. Typically you need roughly 1,000 joules per kilogram of CAPE for thunderstorms and tornadoes to form. However, due to the extreme heat on this day, that level rose to a staggering 6,000 joules per kilogram, or 6 times what is needed. This was essentially a bomb waiting to go off. Aloft in the atmosphere though, things weren't as certain for thunderstorm development. A large stationary front was located in western Iowa, which stretched all the way from the Mexican border to the Canadian border. Along with the front, a weak surface low was situated over northern Kansas, which slowly drifted northeast. The environment was already unstable, but as the day progressed, the front began to slowly recede northward, which would in turn allow moisture to funnel into the area. By mid-afternoon, the dew points had skyrocketed to values approaching the low 70s, which is tropical. Additionally, shear, or spin in the atmosphere was more than sufficient, with 500 millibar winds out of the west-southwest and surface winds out of the south. However, as we've discussed with other tornado events before, like the Grand Island Night of the Twisters in 1980, the one big question mark was would storms even be able to form at all. You see, even with all the explosive environmental conditions in place ready to explode, you still need something to light the fuse, so to say. Typically, a strong cold front or dry line is what's responsible for lighting the fuse in most other severe weather events. This event did not have that, however. This event had a weak, barely moving stationary boundary that most likely wouldn't have been able to fire thunderstorms, but when we take a closer look, we notice something peculiar. These are the 500 millibar winds, also known as the jet stream, which are winds roughly 20,000 feet above the ground. You see these kinks in the line here? These are what's known as a shortwave trough, which is a disturbance in the mid or upper atmosphere that can cause upward motion and can lead to thunderstorm development. These are very small scale and are much harder to forecast, especially back in 1976, but ultimately would have the same effect as a strong cold front or a dry line. By early afternoon, a cumulus field began developing along the stationary boundary and under the shortwave trough. And by 2 p.m., the shortwave trough began to kick into gear, which would finally light the fuse to the volatile environment. Storms would rapidly develop and track northeast. Multiple thunderstorms developed at the same time, but the one of interest was the lead one. Less than an hour after storms initially formed, the lead cell tightened up and produced its first tornado near the town of Perry, Iowa. The tornado tracked northeast for about 6 miles before turning north and then northwest. It would eventually dissolve to the south of the town of Ogden, after remaining on the ground for roughly 9.9 miles. After this, the parent supercell continued moving northeast as it was in the process of recycling. In just 9 minutes after the first tornado roped out, the storm put down tornado number 2. The tornado touched down just to the southwest of the town of Luther and moved towards town. Luckily though for residents, it missed town just to the northwest as it continued to build strength. The tornado continued to rapidly expand and strengthen as it tracked northeast. If it were to have stayed on this track, it would have kept the tornado out of any towns, but just like tornado number 1 did about halfway through its life, tornado number 2 began to turn to the north as it headed straight for the small hamlet of Jordan. At the time, Jordan, Iowa housed roughly 60 people and only consisted of a few dozen buildings. As the tornado began to approach town, Charles Barthold of WHO-TV, who was in the path, began to record. At the beginning of the video, when the tornado was roughly 5 miles to his south, it appeared as a stout but relatively narrow bowl. However, as it grew closer, the tornado rapidly grew in size and strength and very quickly became a wedge. This is where things get a little bit weird though. You see, everything I've told you from the beginning to now is agreed upon by experts. However, from this point forward, there seem to be 2 different theories about the way the event may have unfolded. So first, we'll discuss Dr. Ted Fujita's theory from 1977. As tornado number 2 is approaching Jordan, another tornado forms to the west. This one moves due south, which is the complete opposite direction that tornado number 2 is moving. The two tornadoes continue to move in complete opposite directions as one another as Jordan begins to get impacted by tornado number 2. The tornado approached from the south and engulfed the entire eastern side of town. Meanwhile, Charles Barthold continues to film, which now shows tornado number 2 at peak intensity as it tears through town. At the same time, tornado number 3, which has been moving south, begins to change its direction and turns to the east. Presumably, this tornado began to get pulled back to the north by tornado number 2 in the general direction that the thunderstorm was moving. Tornado number 3 then makes a hard left turn and begins heading due north straight towards an unbeknownst Charles Barthold, who is still watching tornado number 2. He is then abruptly impacted by tornado number 3, which is luckily very weak, but is moving very fast as it continues to get pulled towards tornado number 2. Eventually, tornado number 3, which is moving much faster than tornado number 2, actually catches up to the original tornado and merges with it. Almost immediately after merging, and while tornado number 2 continued moving off to the northwest, the storm put down another tornado. This new tornado was different, however, as it spun clockwise or anticyclonically. In the United States, 99% of tornadoes spin counterclockwise, while less than 1% spin clockwise, hence why this one was so abnormal. Charles Barthold continued to record and documented the new tornado. The new tornado touched down to the southeast of the still ongoing tornado number 2 and also moved northwest. Both tornadoes continued moving in this direction for a couple more miles before something very unusual happened. They both came to a near stop and then made a hard right-hand turn and began moving southeast. Fujita theorized that this abrupt turn was due to the tornadoes encountering outflow from a different thunderstorm which was to the northwest. Both tornadoes continued moving on a southeast course for a few more miles before they once again began to change course, this time turning back to the northeast. Shortly after, though, tornado number 4 dissipates while tornado number 2 carries on. Tornado number 2 continues on this northeast course for another 6 miles or so before dissipating just southwest of Story City. Charles Barthold spectacularly also managed to document the tornadoes as they were roping out. The second theory comes from a paper written by John M. Brown and Kevin R. Knupp in 1980 and goes as follows. They first theorized that as tornado number 2 was heading towards Jordan, tornado number 3 began to form in a different spot. Rather than forming to the west of tornado number 2, they theorized that it formed to the southeast. It then moved northeast in unison with tornado number 2. However, in this theory it did not get pulled towards tornado number 2 and instead stayed about the same distance away from it for its entire life. Another difference with this theory is that this was the only satellite tornado rather than there being 2. Both tornadoes continued moving northeast, then turned north and then northwest before coming to the near stop. Both then made the abrupt right-hand turn and began traveling southeast. Another difference with this theory is that they didn't believe that outflow from a different thunderstorm was the cause of the tornado's sharp right-hand turn. After traveling in this direction for a few miles, tornado number 3 dissipates, which is followed by tornado number 2 a few minutes later to the south of the town of Gilbert. According to this theory, within a few minutes of the other tornadoes dissipating, the storm put down a new tornado, or tornado number 4 to the west of the town of Gilbert. The new tornado evidently rapidly strengthened to F3 or F4 intensity as it moved northeast. Shortly afterwards, though, the tornado began to expand but also weaken as it approached Story City. It would finally dissipate shortly after 4:30 p.m. just to the southwest of town. Even though there were different opinions on the way the event unfolded, there was no denying that the small town of Jordan, Iowa endured the worst of the storm.
Okay, I'm over the town of Jordan now. The town of Jordan, 3 miles east of Boone, has been hit. A grain elevator and 2 farms were destroyed there. The houses were completely leveled. There's an ambulance and several police cars there now. They have been destroyed. There's nothing left, just some foundation. Debris is thrown for about 1.5 miles up here, just all directions. The school that was no longer in use there has been taken down to about the 1st floor. It's completely destroyed. The grain elevator there on the railroad tracks has been toppled. A grain bin on the south side of the tracks there is now on the north side of the tracks. The farm about 1/2 mile north of Jordan has been completely destroyed. The house there has no roof. The barn is gone. Then the next farm north of that has been destroyed. There's outbuildings scattered for about 1 mile. The town of Jordan just no longer exists. Everything is a mess up here.
Luckily and remarkably, there was nobody killed or even injured, but there was still significant damage done in town. Ted Fujita soon thereafter heard about the tornado and was determined to do as much research about it as possible. Just a few days after the twister, he arrived in the small town and began his assessment. He interviewed residents and other eyewitnesses, collected photographic and videographic evidence, and took as many pictures from different angles as possible.
I'm coming here as a scientist, because we do research on tornadoes. And the main reason why we are here is to find out what tornado did. And in case of future tornadoes, what people should do, that's the kind of thing we want to find out. Right after the storm, this is a Greg Post, my student, and I flew over to take a picture of the whole area. And this is one of the pictures which shows that I think it's a grain elevator up here. Could you tell me how big is this and how it happened?
He quickly realized that this tornado was a different beast and described it as one of the most powerful that he's ever documented. Damage surveys found extreme damage, including homes wiped clean off their foundations and ground scouring. Ground scouring is when a tornado is so strong that it rips dirt and soil off of the surface of the ground and can even leave trenches. This is something that you only see in the top echelon of tornadoes. Considering that this tornado produced some of the worst damage that Fujita had ever seen, there was no doubt in his mind that it was an F5, and he formally assigned it that rating. To the present day, this is one of the 11 F5 or EF5s that have hit Iowa, and it's the second most recent to the 2008 Parkersburg EF5. The Jordan, Iowa F5 tornado of 1976 is easily one of the most forgotten F5s of all time, for all the right reasons. The tornado mainly stayed over rural areas and caused no human injuries or deaths. What could have been a much worse situation with a tornado of this magnitude hitting a much more populated area luckily wasn't, which allowed the Jordan, Iowa F5 tornado of 1976 to be placed as a footnote in tornado history.